Okay, 5 out of 10. Not bad, considering how lost I was during this test. So, part A, 0 out of 2. I had acceleration and velocity, but I could have put in root 2gh since what I wanted to do in part 2 was originally was to raise the track at an angle and then just put the blocks in different places on the ramp. So like this. Put the blocks in different places on the ramp. So I could have just put in root 2gh since the only thing really affecting the block is gravity, since friction is claimed to be negligible. So I would need the acceleration, the block goes, the height, the block goes, the distance, the block goes, then the velocity, the block goes. Let's see. For part 2, a 0 out of 2. I crossed out what I originally wanted to do and then put something else. So my mistake here was not realizing that I could have just put this. Oh, I did realize. Oh, I don't know. But I should have just done this. Put it at an angle at a certain height. Put the blocks at like 3 different places on the ramp, so 3 different heights, and then do multiple trials for each height. And if the velocity, and when you drop it, if the velocity when it reaches the bottom is slower than the velocity on the ramp, then that means there's friction. But if the velocity at the bottom is equal to the velocity here, then there should be no friction. And then for part B, it says I just put a bunch of mass stuff, but in this case it would have to be the velocity. So the velocity, it's the velocity when it's on the ramp, and then the velocity when it's off the ramp, I think. Or the velocity it should be versus the velocity when it slows down. Okay. So we'll just call that VT, and then V bottom. And it should produce a linear graph when you plot all the data points. It should produce a linear graph. And then that slope should show us that these two are directly proportional to each other, showing that friction is negligible. And then for the graph, we got 4. Oh, it's just this part right here. I got the slope. I did get the slope pretty close. I think they had 2.8. I had 0.3. They had 0.28. 0.29. I had 0.3. My mistake here was just not plugging it into the equation they gave, which was m equals c minus c over g. So it would just be c equals the mass of the hanger plus the mass of the system plus the mass of the glider. So we would have had to multiply, and since c is just equal to 0.308 meters a second squared over kg, just convert that back into kilograms, basically multiply it by 9.8 meters, which gives like 3 kilograms. Mass of the hanger. Mass of the glider is 0.5 kilograms. And then the washer is roughly about like 1.8 kilograms. Just subtract everything, and I got 0.7 kilograms. Which is between 0.15 and 0.9. So, yeah. So for part, oh shoot, where'd it go? Okay. Part A, just missing a few things, missing the root 2gh and a few other quantities. And then part 2 had the wrong idea. Part B had the wrong things I needed to graph. And then this part I was just missing the whole equation.